Good morning, everyone. This is mathematics class of grade 8, and this is my lecture number 2 of chapter number 13, direct and inverse proportions. So, dear children, this chapter basically consists of two concepts: direct proportion and inverse proportion. Direct proportion, we have discussed this concept in the previous lecture, and in this lecture, I am going to introduce inverse proportion. What is inverse proportion? What are the examples of inverse proportions? And the formula used in the case of inverse proportions. So basically, we will revise direct proportion concept, and then I will be explaining inverse proportion concept in this lecture number 2. So let us recall, if the value of two objects depends upon each other in such a way that increase or decrease in the value of one object affects the value of another object, then these two quantities are said to be in variation. As we have discussed various examples in the previous chapter, like if I need to purchase more pens, I need to pay more. That is, more pens, more cost. Less pens, less cost. If I will be engaging more men at work, then less time will be taken to finish the job. Likewise, two quantities are said to be in variation if increase or decrease in one quantity affects the value of other quantity or another object, then these two quantities are said to be in variation. Now, coming to direct proportion or direct variation, what is direct proportion? If the value of variable x always increases or decreases with the respective increase or decrease in the value of variable y, then it is said that the variables x and y are in direct proportion. It means if the value of variable x always increases, and which results in the increase in the value of variable y, then x and y are said to be in direct proportion. Or if the value of variable x decreases, which results in the decrease in the value of variable y, then also x and y are said to be in direct proportion. As the value of x increases, the value of y also increases, as I told you in the previous slide, in such a way that ratio x over y does not change. It means if the value of x is increasing and the value of y is also increasing, provided the ratio x over y does not change, then both the variables are said to be in direct proportion. And if x over y is equal to k, or x is equal to ky, where k is a constant. So, when x and y are in direct proportion, we can write x1 over y1 is equal to x2 over y2, where y1, y2 are the values of y corresponding to the values of x1 and x2 of x respectively. So, when two variables are in direct proportion, we are supposed to use this relation x1 over y1 is equal to x2 over y2, and in the previous lecture we have seen many examples relating to this concept, relating to this relationship. And I hope you must have completed exercise 13.1 using this concept. Now, coming to the main topic of today's lecture, that is inverse proportion. What is inverse proportion? Two quantities x and y are said to be in inverse proportion if whenever the value of x increases or decreases, then the value of y decreases or increases in such a way that xy remains constant. What does it mean? If two quantities are changing in such a manner that if one quantity increases, the other quantity decreases, and vice versa. That is the case of inverse proportion. As the name indicates, if one quantity is increasing, another quantity should decrease, then those two quantities are said to be in inverse proportion, provided their their product, that is xy, should remain constant. So when x and y are in inverse proportion, then x1 y1 is equal to x2 y2 is equal to x3 y3, and so on. You must have observed that in direct proportion or in direct variation, we have used the relationship that is x1 over y1 is equal to x2 over y2. But when two quantities are said to be in inverse proportion, or they are in inverse proportion, then we need to use this relationship, that is x1 y1 is equal to x2 y2 is equal to x3 y3. Likewise, it means xy should remain constant, but in case of direct proportion, x over y should remain constant. For example, as the number of workers increases, obviously the time taken to finish the job decreases. If I will be having more number of workers, I will be able to finish my job in less time. So this is an example of inverse proportion. Number of workers are increasing, but the time taken to complete or finish the job decreases. So it is a case of inverse proportion. Another example can be taken. If I increase the speed of my vehicle, the time taken to cover the given distance decreases. Obviously, if I will be increasing the speed of my vehicle, I will be able to reach my destination in less time, or I will be able to cover the distance in less time. So this is again an example of inverse proportion, because one quantity is increasing, that is my speed is increasing, but the time taken to cover that given distance decreases. So this is an example of inverse proportion. Let us consider another example. If a school wants to spend rupees 6,000 on mathematics textbooks, a school wants to spend rupees 6,000 on mathematics textbooks, how many books could be bought at rupees 40 each? It is quite obvious 150 books can be bought. Let us see now. If the price of a textbook is more than rupees 40, I told you a school wants to spend rupees 6,000 on mathematics books, but if the price of the books bought or one book is rupees 40, then I will be able to buy 150 books. But if the price of a textbook is more than rupees 40, then the number of books which could be purchased with the same amount, that is rupees 6,000, would be less than 150. Obviously, if the price of one textbook is more than rupees 40, then I will not be able to buy 150 books. Let us see this example with the help of a table. Here one table is being made. In this table, what have you observed? You will observe that as the price of the books keep on increasing, the number of books that can be bought will keep on decreasing. But this ratio remains constant, like 40 into 150. How much you are getting? 6,000. 50 into 120, you will be getting 6,000. Again 60 into 100, 6,000. 75 into 80, 6,000. So likewise, the price of the textbook is keep on increasing, but number of books that can be bought keeps on decreasing, provided this is x, suppose, and this is y, provided xy remains constant. That is 40 into 150 is equal to 50 into 120. As I told you, in case of inverse proportion, you are supposed to use the relationship x1 y1 is equal to x2 y2 is equal to x3 y3. And you have seen in this example that this product remains constant. Thus, two quantities are said to vary in inverse proportion if there exists a relationship of the type xy is equal to k between them, k being a constant. This is what I told you in the previous example. So, if x and y are in inverse proportion, it can be said that x1 y1 is equal to x2 y2, where y1 and y2 are the corresponding values of the variables x1 and x2. Simple as this. Now, so dear children, in this lecture, we have learnt the concept of inverse proportion, and we have seen with the help of the examples that if one quantity increases, the other quantity decreases, and vice versa in case of inverse proportion, provided xy, that is one variable I am taking x, another variable or quantity I am taking y, provided their product remains constant, that is xy is equal to constant. So I can use the relationship x1 y1 is equal to x2 y2 is equal to x3 y3, and so on. So let us see now homework from NCERT. So dear children, you are supposed to complete question number 1 to question number 11 of exercise 13.2 in your homework notebook, but question number 2 to question number 5 I will be discussing in the further slides. So basically you are supposed to complete this exercise, but few questions I am explaining in this lecture. Let us see now NCERT questions, exercise 13.2. Question number 1, this is basically question number 2 of your NCERT. In a television game show, the prize money rupees 1 lakh is to be divided equally amongst the winners. Complete the table and find whether the prize money given to an individual winner is directly or inversely proportional to the number of winners. We need to find out whether the money given to an individual winner is directly or inversely proportional to the number of winners. So let us see. We know that when two quantities or two numbers are in inverse proportion, their product should be constant, that is xy is equal to k, or x1 y1 is equal to x2 y2. Let us verify for inverse variation, then we will come to know if inverse variation will not be valid, will not hold good, then it will be a case of direct proportion. So here I will be using first the case of inverse proportion. This is the table given to you, and these are the unknowns. After finding the unknowns, we will see whether this xy is constant or not. Then we will be able to find that whether this is a case of inverse proportion or not. So let us take x1 y1 is equal to x3 y3. x1 is 1 and y1 is 1 lakh. So we have put the values. So after solving, you will be getting y3 as 25,000. Or you can see in the given table that if you will be taking their product, I am showing you the table again. Let us have a look at the table. As I told you, if it is a case of inverse variation, xy should be constant. So this is what 1 lakh you will be getting. And if you multiply this, you will again get 1 lakh. So surely this is a case of inverse variation. Now we are sure that this is an example of inverse variation. Now what we will be doing, we will be taking this x1, x and y. This is x1, this is y1, this is x2, this is y2. This is x3, this is y3. So I will be using x1, y1 and x3, y3 because y3 is unknown. So I will be using x1, y1, x3, y3. Now as I told you, as I explained now, x1, y1 is equal to x3, y3. So it will be 1 into 1 lakh is equal to 4 into y3, and you will be able to get the value y3 as 25,000 after cancelling out. Now likewise, you will be able to find out x4 y4. So again, I have taken it with respect to first value that is given to us x1 y1, that is 1 into 1 lakh is equal to 5 into y4. What will be the value of y4? It will be 1 lakh divided by 5. So you will be cancelling out and you will be getting 20,000. So y4 will be 20,000. x1 y1 is equal to x5 y5. Again, you need to get the value of y5. You will be getting 12,500. And again, the last for the last value, x1 y1 is equal to x6 y6 is equal to 1 into 1 lakh is equal to 10 into y6, and after cancelling out you will be getting y6 as this 10 will get cancelled out with this, so you will be getting 10,000 as the answer. So y6 is 10,000, y5 is 12,500, and this is the last value. X1 y1 is equal to x7 y7. So after cancelling out, you will be getting y7 as 5,000. So we have completed the table now. And in the table, we were supposed to find out whether that was a case of inverse proportion. We have seen that. And using that concept of inverse proportion, that xy should be constant, we have calculated the values of unknowns in the given table in question number 2. Let us talk about question number 3. Rahman is making a wheel using spokes. He wants to fix equal spokes n in such a way that the angles between any pair of consecutive spokes are equal. This n is not at all in the question. It was written by mistake. So the question is, Rahman is making a wheel using spokes. He wants to fix equal spokes in such a way that the angles between any pair of consecutive spokes are equal. Help him by completing the following table. This is basically in such a way. This is the table given to you. And number of spokes are 4, 6, 8, 10, 12. This is x and this is y. Okay, this is 90 degree angle, this is 60 degree. Likewise, we need to find out these unknowns. So again, I am giving the names x1 y1, x2 y2, x3 y3, likewise x4 y4, x5 y5. You can use these two relations together because these two x2 y2 are known, or it can be used, or we can find out y3 using x1 y1 also. So it is up to you. You can take x1 y1 is equal to x3 y3, or you can take x1 y1 is equal to x3 y3, or it can be taken x2 y2 is equal to x3 y3. Both are correct because two variables x2 y2 and x1 y1 are known to us, so we can use those, any of these. First question is, are the number of spokes and the angle formed between the pairs of consecutive spokes in inverse proportion? We need to find out whether it is the case or not, whether it is an example of inverse proportion or not. Second part is, calculate the angle between a pair of consecutive spokes on a wheel with 15 spokes. We need to find the angle if the number of spokes are 15. And third question is, how many spokes would be needed if the angle between a pair of consecutive spokes is 40 degree? So in this second part, spokes are given to us. In this third part, angle is given to us, and we need to find number of spokes. So let us see. Let us talk about question number 3, first part. If the number of spokes increases, then the angle between the spokes decreases. As we have been given two values in this, for number of spokes, when number of spokes were 4, the angle was 90 degree. But when the number of spokes increased to 6, the angle between a pair of consecutive spokes decreases. That is, it is given to us in the equation 60 degree. So basically, it is a case of an inverse proportion because number of spokes are increasing, but angle between a pair of consecutive spokes decreases. So we will be using this relationship, that is x1 y1 is equal to x2 y2. x1 y1 is equal to x3 y3. So 4 into 90 degree divided by 8, you will be getting, I hope you will be able to solve this. It will be 4 into 90 divided by 8. It will be 45 degree. Simple as this. If I need to find out another value, x1 y1 is equal to x4 by 4. Likewise, you will be able to find out y4 is very simple to find out. It will be 4 into 90 divided by 10. It will be 36 degrees. y4 is 36 degrees. Now x1 y1 is equal to x5 y5. So again you need to solve this. 4 into 90 divided by 12. It will be solved like this. It will be 30 degrees. So I have completed the table. These are the unknown values I have written. It is 45 degree when the number of spokes are 8. When the number of spokes are 10, it is 36 degree. When it is 12, it is 30 degree. And now we need to find out number of spokes. When number of spokes are 15, what will be the measurement of the angle? So let us see now. I have taken that x2, y2. Again, you can take any other variable also. So we need to find out, I am taking first two values, that is when number of spokes were 4, angle is given to us as 90 degree, and now number of spokes are 15. I need to find the angle. So x1 y1, this is x, number of spokes, this is the angle. X1 y1 is equal to x2 y2. So I have put the values and simply you will be able to solve it. So it will be divided by 15. Here it will be 15. So you will be able to get the answer. Y2 as 24 degree. So the angle will be 24 degree when number of spokes are 15. So the angle between the pair of consecutive spokes on a wheel with 15 spokes is 24 degree. Now for third part, the question was, how many spokes would be needed if the angle between a pair of consecutive spokes is 40? Again, I am using that 4, when the number of spokes were 4, angle is 90 degree. And now number of spokes we need to find out, and angle is given to us as 40 degree. So this is x, this is y. X1 y1 is equal to x2 y2. Again, I am using this. So x2 is unknown. You can see here in the, I have made a short table. You can see here this x2 is unknown. So that is why x2 I have not written. So after cancelling out, after solving, what you will be getting, 4 into 90 divided by 40. You will be cancelling out and you will be getting x2 as 9. So if the angle between a pair of consecutive spokes is 40 degree, this is 40 degree, then spokes on the wheel will be 9. This is what we have calculated. Now talking about question number 4. If a box of sweets is divided into 24 children, they will get 5 sweets each. How many would each get if number of children is reduced to 4? Now, as I told you earlier also, it is always better to make a table in case of direct and inverse proportion. Take any of the variable or any of the quantity as x variable and other quantity as y variable. So I will be showing you, or I will be making a table, then it will be more clear to you. If the number of children will decrease, first of all you should analyze the question and find out whether it is a case of indirect proportion or inverse proportion. Now let us see in this question, if the number of children will decrease, the number of sweets each child get will increase. Obviously, if I will be having less children to distribute the sweets, then number of sweets which each child will get will increase. So this is a case of inverse proportion, because number of children are decreasing but the number of sweets will increase. So this is the table basically. Number of children I have taken x, number of sweets I have taken y. So when number of children were 24, each child was getting 5 sweets. But it is written in the question that if number of the children is reduced by 4, it means earlier it was 24, now it has been reduced by 4, so it will be 20 now. So I have written 20 here. Now I need to find out how many would each get if number of children is reduced by 4. I have reduced the number of children. Now this is what I need to find out. So this is x, this is x, this is y. X1 y1 is equal to y, x2 y2. So 24 into 5 is equal to 20 into y2. So after solving like this, 24 into 5 divided by 20, you will be able to get answer as 6. So number of sweets which each child will get will be 6. So this is question number 4. Let us talk about question number 5. a farmer has enough food to feed 20 animals in his cattle for 6 days, how long would the food last if there were 10 more animals in his cattle? If the number of animals will increased to 10, like earlier there were 20 animals, now if there will be 30 animals, for how many days or for how long would the food last in that case if 30 animals will be there in total? So let us take or make a table first. Number of animals I have taken X. Number of days to feed animals I have taken Y. So it is given 20 animals to feed, a farmer has enough food to feed 20 animals in a cattle for 6 days. He is feeding the 20 animals for 6 days. If the number of animals will be increased to 10. If 10 more animals are added, so I have taken 30 here. Now I need to find out how long would the food last. So this is a case of inverse proportion. If the number of animals increases, the number of days they can be fed will decrease, obviously. So this is a case of an inverse proportion, and we know the relationship in case of inverse proportion. X1 Y1 is equal to X2 Y2, and we have been given the values that 20 animals are being fed for 6 days. So X1 Y1 is equal to 20 into 6 is equal to X2 Y2, that is 30 into Y2. So after solving 20 into 6 divided by 30, you will be getting answer as 4. So the food would last for 4 days for 30 animals. So dear children, I hope you have understood the concept of inverse proportion and you will be capable enough now to complete exercise 13.2. Thank you so much.